All right. So this is Hacker Machine Interface, State of the Union for SCADA HMI Vulnerabilities. It's not, I don't want the title slide here to indicate that this is about stuffy shirts and racks. I mean, this is about hardcore exploitation in this talk. We're going to cover an in-depth analysis of a corpus of 200 plus confirmed HMI vulnerabilities that have come through the Zero-Day Initiative program. We're going to detail out the popular vulnerability types that have been discovered in these HMI solutions, and we're going to talk about how they're developed and how the weaknesses actually manifest in the underlying code. We're going to talk about some of the biggest SCADA vendors that exist on the planet, including Schneider Electric, General Electric, and Advantech. But all of the vulnerabilities that we're going to be talking about can be applied to pretty much every SCADA vendor that's out there today. This talk will also cover and compare a time-to-patch performance for the various SCADA vendors in the industry, and we'll also compare the SCADA industry itself against the other entities in the software industry. And finally, we're going to use the data that we presented to provide you additional guidance on what SCADA researchers should be looking for in HMI solutions and what we can expect in future attacks against SCADA HMI solutions. But first, let's introduce ourselves so you know who we are. I'll let Fritz introduce himself.
Good day. My name's Fritz Sands. My Twitter handle is Fritz Sands because I'm occasionally boring. I was a longtime developer at Microsoft, 25 years in the Windows operating system, and then I joined the Trustworthy Computing and Secure Windows Initiative in 2001 when the big security push happened at Microsoft. I left Microsoft in 2014 and joined the Zero-Day Initiative, where I have been investigating software in the real world, which has given me a deep appreciation for the code quality at Microsoft, which I did not have when I was there.
So I'm the Senior Manager of Vulnerability Research in Trend Micro's Tipping Point organization. My primary responsibility in this job is to actually run and manage the Zero-Day Initiative program, which represents the world's largest vendor-agnostic bug bounty program. We've been in operation for 10 years. We spent over $13 million on vulnerabilities over those years. We do a lot of root cause analysis, working with researchers around the world to buy bugs, define how they actually fire, and help the vendors get them fixed in a proper way. I'm also the organizer of the ever-popular Pwn2Own hacking competition, where I spend probably over $500,000 this year just on exploits against the hardest attack surfaces in the world. So before we get started, we want to give you kind of an overview and level set everybody in the audience about what we're talking about here, what the SCADA industry is, what HMI is, and who are the heavy hitters in this industry. A lot of the marketplace, if you look at it, is really focused on developing hardware and selling control systems and not so much focused on the selling of the HMI solution itself. In fact, many of them are freely downloadable, which makes them good targets for auditing. So in this case, they kind of focus on software or software that runs on hardware and less on Windows applications, and that really shows in the type of vulnerabilities that we're seeing come through the Zero-Day Initiative program. It is a highly regionalized market. So there are vendors in China that specifically develop SCADA software and hardware for Chinese implementation. There's also ones in Germany, and we've even seen code developed by Italian developers. So it's a very active market, and if you are focusing on SCADA products in one region, it'll be completely different in another region. As you can see on the slide, we've got a bunch of big names on there. That Wecon brand is the one that is actually for China. I personally found a dozen bugs in their HMI solutions and submitted them and had them fixed. Siemens is also a major brand, and GE Electric, or General Electric, Advantech, which we'll talk heavily about in this presentation. Now, there is also a lot of mergers and acquisitions in this space. It's very much like the rest of the software market, lots of buying, lots of selling. And the one interesting thing that we find is when we buy a vulnerability in some of the mom and pop SCADA HMI shops, which there are a lot of them, we'll see that by the time the patch comes out, they've actually been acquired by one of the bigger companies like Schneider Electric or Siemens. So there is a lot of merger and acquisition that goes on, which makes the disclosure process a little bit more complicated. If we look at the human-machine interface, what exactly is it? Well, its primary job is to provide status of the critical infrastructure, things like alarms, notifications, They also provide highly advanced and customizable visualizations that give operators insight into what is going on in their critical infrastructure. And a lot of these, you can kind of develop these and customize these visualizations for different components in your actual infrastructure. Now, they're supposed to be air-gapped and run on isolated and trusted networks, but this is really not always the case, and we'll talk about attacks here in a couple minutes where they took advantage of HMIs that were not on isolated networks. Now, even isolation is not guaranteeing security. If you ask the Iranians, back when Stuxnet came out, the air-gapped network didn't really provide them much value when they were being exploited using USB link vulnerabilities that existed. So if the developers are actually spending the time and thinking that the fact that their HMI solutions are going to be used in air-gapped networks and not putting security in, that's what we're seeing in the code. That's what it feels like. They're not actually spending a lot of time implementing best practices of the industry. So why would you target an HMI solution as an attacker? Well, it's because it controls the infrastructure. You can actually see and get configuration information about the devices on the network, and it can actually be used by itself without a vulnerability to shut down a network, to shut down critical infrastructure. This is the case in the Ukrainian attack that happened at the end of last year. The attackers who were going after the Ukrainian power companies just used the HMI solution by itself to trip breakers and shut down the power. And they were not actually exploiting HMI vulnerabilities, but they were using the HMI system to actually take the systems down. Now, it can also be used, you can actually attack these to deceive and disable alarm systems in the control system itself. And this is the case in Stuxnet, where they actually deceive the operators and about the state of the centrifuges that they were controlling, and actually send commands to trigger self-destruction conditions in the actual control systems themselves. So there are active attacks in HMI solutions. If we look at, Stuxnet is obviously the most popular one that we talk about. Everybody knows about this one, but it did leverage vulnerabilities in HMI solutions, including Siemens Semantic Step 7 DLL hijacking vulnerability, along with a SQL server authentication bug. Right? So these are really simple bugs, very common bugs in HMI solutions, and it leveraged those to deceive the operators about the state of the centrifuge. Now, BlackEnergy is an ongoing sophisticated malware campaign against ICS environments, and it actually does target HMI vulnerabilities. The GE Simplicity path traversal vulnerability, it's used. We believe it to have used some vulnerabilities in Siemens WinCC and Advantech remote web access. So quite famously in the ZDI program, the GE Simplicity vulnerability is actually one that we purchased from an anonymous researcher and disclosed the ICS cert, and it turned out that that was actively being used by BlackEnergy. So it's kind of interesting to see that happening in the wild. Now, another big player in the industry is ICS cert. And as a researcher, you need to understand who this organization is and where they sit in the government. So I'll rattle off the title and their location in the government. They're the Industrial Control System Cyber Emergency Response Team, which operates within the National Cybersecurity and Integration Center, a division of Department of Homeland Security's Office of Cybersecurity and Communication. I mean, that's a long name. I'm almost getting paid by letter there. So, but in reality, they are a very important organization, and people who are researching in HMI need to know who they are and learn how to work with them. We work with them every day in our jobs because we're purchasing a lot of vulnerabilities in HMI. And they do a lot of things. They actually release a report every year about all the stuff that they're doing. And according to the 2015 report, they actually responded to 295 incidents and handled 486 vulnerability disclosures. And that's significant. That's a lot of vulnerabilities passing through that organization every year. Because it's so regional, it's often hard to get a hold of these mom and pop organizations when you find a vulnerability in their solution. And at this point, you come to programs like the Zero Day Initiative or go to ICS CERT to help you disclose those vulnerabilities and get them fixed. So let's talk about attacks that leveraged HMI features or vulnerabilities in their active attacks. If you read the Verizon data breach report, they talk about an incident where their team went in and actually was called in to analyze the security of a water utility. Now, they don't give the name of the water utility, but they do talk about their findings, And in this case, they found that there was an internet-facing AS400 system responsible for HMI-like capabilities, like manipulating PLCs. But this system also did network routing and managed customer data. I mean, how ridiculous is that, that all of that information is sitting on one system connected to the internet, both critical infrastructure and billing systems. This is kind of an example, prime example, that there's no focus on the separation of responsibilities when they're architecting these critical networks. Now, what they learned is, what they discovered was there are 4 separate connections to this AS400 over a 60-day period where the IPs were tied to hacktivist activities, and they actually altered the water flow and the chemicals in that system. Now, according to the report, they say that the attackers really didn't understand what they were working against, and they didn't do a lot of damage, but they could have done a lot of damage by accessing that system. The most recent example of a really high-profile SCADA attack was in the Ukraine, where there are several Ukrainian companies that experienced unscheduled power outages, which affect almost 250,000 people. These were caused by malicious actors, and there's actually a really great report on the ICS website, ICS CERT website, that describes all the details about that attack that are unclassified. And they talk about how the attack was coordinated, and they all attacked within 30 minutes. And in this case, they didn't use HMI vulnerabilities, but they leveraged that HMI solution. Because there's no isolation, they were able to VPN into the network and get access to the HMI solutions and use remote administration tools, which DOSed the operators from making any changes. And they actually just tweaked the knobs in the HMI solution to turn off and trip breakers. And as a result, the power went out. They also put kill disk malware on the Windows-based HMI systems, which basically brought them to their knees and really hurt the restoration efforts. Now, this is obviously used to destabilize the Ukraine a little bit. I don't think they've actually attributed the attack, but there is a lot of political stuff going on in that region, so you can imagine. Now, there's also some interesting research that came out of a sister organization here inside of our company, where they actually looked at the malware that was used in the Ukrainian attack and actually found links to malwares in other companies in the Ukraine, including a rail company and a mining company around the same time. Now, BlackEnergy was supposedly not used in the attacks against the Ukrainian power company, but it did exist in that network. So you can imagine that the attackers who were going after those are probably the same attackers who had access to some rail and mining companies in the Ukraine as well. How did our sister organization know this? They looked at the infrastructure of the malware and the naming conventions that were used, and they released a white paper on it, and it's actually really, really interesting, and it's worth a read. It's on the Trend Micro blog. So let's talk about the prevalent vulnerability types that exist in HMI solutions and what the current state really is. So the reality of the situation is the HMI solutions have not seen any benefit of the evolution of secure software development life cycles over the last 10 years. We have looked at a lot of the code, dozens and dozens of code bases. We've analyzed and looked at vulnerabilities and confirmed 0 days, and that's what we've learned. There really is no security built into that software. They haven't seen any benefits of the secure development lifecycle that Microsoft, Apple, all these other companies have, and this is actually a really scary thing. And in fact, most of the solutions that we're vetting bugs in do not have ASLR, safe SEH, or stack cookies enabled, which is really, really scary. And we actually urge SCADA vendors to turn on all of these mitigations, including things like building 64-bit apps and to make ASLR better, and actually reducing the reliability of heap sprays, and also turning on just the basic mitigations that are available by flipping a toggle in the compiler. It's actually really embarrassing. There's also a lack of understanding of how these solutions are actually run. They seem to think that they're going to be running that isolated environment, and they're using that as a way to not implement security mitigations, but they are continually being integrated, and you've seen attacks in the wild that leverage interconnected HMI solutions to take down critical infrastructure. So this is probably the only pie chart that you're going to see at DEF CON, and I'm actually really proud of that because I did a lot of work to generate this pie chart. But what we ended up doing was we pulled all the 2016 and 2015 ICS CERT advisories, and identified all of the HMI solutions that had bugs fixed over the last 2 years. We cross-referenced that with our 250 plus zero-day vulnerabilities that we've purchased in HMI solutions to come up with what the most common vulnerability types are in HMI solutions. We also cataloged the CWEs to kind of get an idea of what vulnerabilities existed, and here they are listed on the slide. So the number one is memory corruption, followed by credential management, usually hard-coded passwords, insecure defaults, authentication and authorization, and code injection issues. Now, what about cross-site scripting? What about cross-site request forgery? Well, most of these are Windows-based applications. There are some web-based applications, but most of them are Windows, and as a result, you're not going to see a lot of that cross-site scripting stuff. But there are some in that gray area on the slide. So what we're going to do is let's get down and dirty with this. Let's look at every single one of those categories, and we're going to give you case studies of what these look like so you can understand how terrible this code base really is and what you need to understand to actually go find these bugs and to protect yourself against these bugs. And that's the most important part. So first, we're going to talk about code injection vulnerabilities. This makes up about 9% of the common vulnerability types that exist in these products. And that, it's the classic stuff: SQL injection, code injection, OS command injection. But there's other domain-specific languages that exist in this software. And that's what we're going to talk about today. We didn't want to cover like stuff you guys already know. We're going to talk about gamma code injection, right? So this is a domain-specific language that's used in this industry. Specifically, we're going to talk about Cogent Data Hub, and we're going to talk about CVE 2015-3789. Now this vulnerability actually allows an attacker to turn on an insecure processing mode in the web server, which allows the attacker to send arbitrary scripts to the server and execute arbitrary code. This was discovered by an anonymous researcher and purchased by us, disclosed to ICS Cert and fixed. Now we do offer the ability for people to submit bugs to us in an anonymous fashion, and we get a lot of that actually through our program. So what is Cogent Data Hub? Well, that's what you see on the screen here. That's one of those visualizations that I was talking about. Cogent Data Hub is a real-time middleware solution that is deployed across several sectors, including chemical, commercial, critical manufacturing, energy, financial, et cetera, and it's used around the world. It offers the end user the ability to create those really intense, advanced visualizations, which you see on the slide here, customize those so they can monitor their underlying network. So what is GammaScript? Well, GammaScript is a domain-specific language specifically designed for the use within Data Hub. It's a dynamically typed interpreted programming language specifically designed for rapid application development. It looks like C, and I'll show you some here in a second, and it has a range of built-in features. It's got libraries and everything. It actually has a fully documented API that you can read on the internet, and it's actually pretty full-featured for those application developers. Now, the attack itself is a flaw in a val expression method, and it allows an attacker to execute arbitrary code on the system. It actually sits and is accessible through an AJAX facility on port 80, and you simply supply a well-formatted gamma script which allows the underlying code execution. Now, the interesting thing about this is it is domain-specific, so there's a lot of functionality in Gamma that's specifically used for developing that stuff, but unfortunately, it did have in that script the ability to execute system commands. And so what is the vulnerable code? It's right here on the screen. It's very, very simple. A val expression basically takes an expression and checks one flag. Am I allowed to execute this expression? And if it does, then it executes the expression, right? And this is whatever you want to send to the system. Now, the question is, how do you actually get that to load up, and how do you change that value? Well, it also allows you to do that as well. And the exploitation steps are you send a request, an HTTP request, to the port 80, which will load the GammaScript libraries. Then you call AJAX support.allow expressions, which will set allow any expression to true. And then you call a val expression with whatever script you want, and you execute code. So let's demo that exploit. So what you see here is an installation of Data Hub. You can see, let me kind of zoom in for the audience here. Oops. Yeah, well, forget that. So what we're going to do is right here on the screen, what's highlighted is Cogent Data Hub version 7, and it's running and sitting on port 80. And what the first thing we're going to do is we're going to run a proof of concept here at the bottom that is just basically a Python script that sends the 3 commands that we need and will actually disclose information on the server. It actually is disclosing autoexec.bat on that box. So then we're going to send another script which will actually execute the evil calculator. And you'll see here, it's actually a very, very reliable bug and a very reliable exploit. You can just kind of send it over and over and over again, and there's those evil calculators, you know. So that's a pretty fun bug, really simple bug. And they did actually do a really good job fixing it. And you can see here all the calculators being spawned by the process. So now how do they patch the bug? Right? This is kind of one of the interesting things for the ZDI program, because when bugs get patched, researchers will also submit bugs, POCs that actually break the patches, which is kind of interesting. But here it's going to be kind of difficult. So on your left is the old code, and on your right is the new code. And you can see up here that they actually removed allow expressions, so you cannot access that at all. So you can no longer toggle that flag in the system. They also removed a val expression entirely, and they actually gave it a really great comment, which is actually a best practice. This method is dangerous. It could allow somebody to execute arbitrary code via an HTTP call. And if you absolutely need it, create a script and define it, and then make sure that your web server is on a trusted network. So that code is buried in the application itself, so it's highly unlikely that a developer is going to go look at that, but they're just going to call the APIs. But it is good that the fact that they actually documented that so they won't regress that bug at some point. So that's how that bug actually works. So I'm going to turn it over to Fritz, and he's going to cover the rest of the prevalent vulnerability types, and then we'll talk about some disclosure statistics.
Hello again. So the next section we're going to look at is authentication and authorization problems. And authentication bypass, improper access control, improper privilege management, bad authentication, and what we're going to focus on is an Advantech case, and you're going to hear Advantech a lot. And this is actually a pretty fun one. And it's information disclosure. And this is CVE 2016-5810, and ICS Cert says a properly authenticated administrator can view passwords for other administrators, but the terminology is a little unfortunate here, because this is not a system administrator. This is an administrator of a given SCADA solution, a given project. And so that is sort of akin to unprivileged users of the system. So this is in essence saying one user can extract the password of another user. And this was discovered by Zuyu and disclosed by the Zero Day Initiative. And it's sort of fun. And basically they have a script, an ASP script that allows you to change your username, your password, your description. And this is great, but it can be abused. And the way you do it is you log in to the account you have. So this is not anonymous. You have to have an account on the system. But then you can change the URL to give any other name and then pass that in, and it will bring you back the password of the second account. Now, you can't see the password because it's got asterisks in front of it. Yeah. So here's the demo showing it. So first, log in as the admin, and by the way, you can also get the full system administrator account this way. And you can see that there's a test 1 and a test 2 user. So now you log in as test 1 and put in your password for test 1, and that's all great. Now if you try to change to test 2 using the UI, it will quite properly give you an error saying you can't do that. But if you change to a username of test 2 in the URL, it will pop it back, but it's got those asterisks, so we got to fix that. So you view the source. And there's the password. And then you can use that password, of course, and log in as anyone else, including, of course, the complete system administrator of all of the solutions. And there you got it, and you're logged in. And what? Okay, here it goes. So that one was sort of fun. And there's also a lot of insecure defaults in this space. Bad transmission of information, missing encryption, unsafe ActiveX controls. Yes, we're back to ActiveX controls. So the one we're going to focus on here is the Schneider Electric DS-NVS. And this is a bad ActiveX control with memory corruption. Now, even though it's memory corruption, we put it in here because this ActiveX control, well, first it was set as safe for scripting from untrusted source. But what's also interesting is it was never meant as a control to be used in Internet Explorer, in a web page. So it should have been configured as automatically kill-bitted. So it's really bad configuration. So it was wide open to Internet Explorer when it should not have been. And this is CVE 2015-0982, and the Schneider Electric Pelco here is an HMI for digital sentry video surveillance systems. So it's really great. You can use this to, get information on video surveillance systems, which is always fun. What I wanted to do was show this for people who are going and auditing looking for ActiveX controls that might be vulnerable. This shows an interesting second step you often need to take. There are two ways to tell the system that an ActiveX control is not safe for scripting. The standard way, the fast way, is statically in the registry to mark it as not safe for scripting. But if you note, to turn it on, to make it safe for scripting, is to flag it as safe for scripting. But if it's not marked in the registry as safe for scripting, it can use the interface iObject safety and in dynamic runtime assert that it is safe for scripting. So even though it's in the registry as not marked as safe for scripting, it still is potentially vulnerable. So you've got to look at the dynamic situation as well as the static situation. So you can't just do one. And here's just the demo of how the memory corruption works, which is you use Internet Explorer and you go to an attacking web page which invokes the control in IE, and it does a stack buffer overflow and fills everything with your classic 41s that we all know and love. Now let's talk about some credential management problems. This actually, I was really shocked when I ran into this because it's like, you're kidding, right? This happens a lot, that they hard code credentials in the code, hard coded passwords. I thought we'd gotten rid of that 15 years ago with IIS, but well, we're in SCADA space. You're hacking like it's 1999. It's awesome. It's awesome. We're back then. So this is the one we're going to look at is GE MDS PulseNet, and it's got a hidden support account, and this is really fun. So this is used to monitor devices in industrial communication networks, and it's deployed in energy, water, and wastewater sectors, and it's used worldwide. This is CVE 2015-6456. So if you take a look at the user management panel, using the UI, you see that there are exactly two accounts in the system. There's an admin and an operator. Well, that lies. If you go in and use, I used Heidi SQL, but if you use anything that extracts information from the database, you see that there are not two accounts, there are three. There's a hidden account called GE Support. Now it's really super subtle because it only stashes the MD5 hash of the password, not the password itself. No one here could crack an MD5 hash, right? It turns out that the password is actually PulseNet, but they made it leet by changing the L to a 1. And here's the demo. You can see on the right the two users that are officially there, and on the left we will log in as the user that isn't there. And what I think is really cool is that even after you log in as the user that isn't there, as you're logged in as the user that isn't there, it tells you that that user is still not there, which is sort of slick, I think. There's also a lot of other misconfigurations. One of the other ones that we see a lot is where companies decide to roll their own ACLs, and they decide they don't want to put things under program files as Microsoft intended. And so they create their own top-level directory with their company name under the C drive, and they often put, world has full access. And then they put their service binaries in there. So any local user can drop new binaries in, and they will run as a system service. So this is very standard. Now we get to the joy of memory corruption. Stack-based buffer overflows, heap-based buffer overflows, out-of-bound, read-write, just the classic ones. And the Advantech is our whipping boy here because they did an awesome job here. We got 100 bugs in one day from an anonymous researcher. This was like this data dump from heaven. And we analyzed them and passed them on, and they were all buffer overflows. And it was quite impressive. And I'll go drill into one in particular. This is CVE 2016-0856, and it was an anonymous researcher and disclosed by us. And this is their web page. And what's really interesting about web access is it's a SCADA solution, but they also advertise, as you can see in here, that this is for Internet of Things. So this is widely deployable, and it's awesomely vulnerable. It launches a service, web VRPC, in the context of local administrator, and listens on 4952. And the service calls are configured to look like Microsoft IO access control calls. So they've got an ioctal value, and they do jump tables off of that to perform hundreds and hundreds of types of services. For this particular one, the parameter that's passed is a window name, which is then copied using sprintf to a stack buffer that is hex 80 characters. And as you can see in this packet, the length is hex 8c. So it copies hex 8c bytes into a hex 80 byte buffer on the stack with predictable consequences. And so inside, you've got this, and the flaw is the stack-based buffer overflow. Here's the classic sprintf call. Nothing of a surprise there. Here is the stack layout, and this is sort of fun because you can tell the Windows name is at -80, and then 0 is your return address. No stack cookie. Why no stack cookie? They didn't flip the bit in the compiler and linker. Probably because they first built this 20 years ago, and they never changed their configuration to add ASLR, to handle safe SEH, to handle stack cookies. So all you have to do is overwrite the return address, point it to the first of your op. You can handle the ROP chain well because there's no ASLR. Life is good. Life is really good. So you can see us jumping to an address, and here I will pop the glorious calc. And this was fun to do. Bingo. And that's running at high privilege. Life is good. Let's talk about the patch analysis. Look, sprintf, Microsoft published the banned API list a decade ago. And there's a reason why Microsoft published the banned API list. And so what they did when we reported this is they changed sprintf into snprintf. Now, snprintf is also in the banned API list. Now, it's a better banned API because it won't buffer overflow. But if you give it too many characters, it also will not null terminate. So if the stack is not pre-cleaned out, and it isn't, it is possible for you to then use string manipulations on this window name where you think it's hex 80 characters long, where it may be longer because it didn't null terminate with the copy. So there still may be problems. As I said, 100 bugs came in. 100 bugs. Advantech fixed 75 of them. We have disclosed the other 25 as not fixed. You guys can enjoy. There are also, when they did fix, they did not do any kind of global replace. They did specific point fixes of the ones that they fixed. There are thousands of string copies, sprintfs, etc. in the code base. And I would not bet 10 cents that none of those can be reached by attacker-supplied data. So have fun, guys. Have lots of fun. Ah, yes, researcher guidance. So, what do you people want to do? Well, the first things to do is fuzz, right? These things are easy to fuzz. They don't have CRCs. Most of these file formats are wide open. Just do bit flipping. Remember to turn page heap on the process that's being attacked. That's a great way to find memory corruption because then it breaks at the corruption point, not later on when it's being used. Use your tools that you've got for fuzzing. Use your tools for analysis. SQL map is great for finding SQL injection possibilities. One of my favorite tools is Attack Surface Analyzer by Microsoft. One of the reasons it's one of my favorite tools is I helped write it. Microsoft released a public version in 2012. It creates a snapshot before and after the installation of your target software. And then it will highlight security problems in the configuration, and it will highlight increases in attack surface. So it'll show you your new COM objects, your new ActiveX controls, your new RPC endpoints. Here's an example. It shows you, for example, on the Advantech software of the new RPC information. And here is Attack Surface Analyzer telling you that the web root directory, which is, you know, where files are going to go that are being executed in the high-privileged web server context, that this entire directory has write access by the world. What could possibly go wrong? So ASA is a great, great tool to use. Now, if anybody in here has pull at Microsoft, we need a new version drop of ASA because it doesn't work on Windows 10. And if Microsoft wants to be really cool, they could release the source of ASA because I know what needs to do to fix it so it works on Windows 10, and it would take me about an hour if Microsoft would please release the source. Also, audit for banned APIs. Go look for the sprintfs. Go look for the stir copies. Use IDA to trace the tainted data back and see if you can get to the source of these unsafe copy APIs, if you can get to those from attacker-supplied data. IDA's great, just, you know, it's wide open, people. And now back to Brian for more of the corporate things.
Yes. So we wanted to give you an understanding of how, when you find a vulnerability, how long it will actually take to fix. Kind of talk about the vulnerability exposure window. So what we did is we actually took all of the HMI vulnerabilities that we've received in the Zero-Day Initiative program, again, over 250 now, and looked at how long they actually took. And if you look at the last 4 years, it's not exactly trending down. You know, it's pretty consistently about 140 days from the time that we disclose a bug to when the patch comes out. And the thing about the SCADA industry is that when they're applying those patches, if the patch is bad or there's an issue, it will actually denial of service the critical infrastructure as well, which is not good. But that means that patching actually takes a really long time. It's almost, you could imagine, almost twice as long. So that leaves, you know, almost probably around 300 days when the patches are not being applied. So, you know, that's how long the bug are existing in the software even after you find them. So what we wanted to do is actually call out a couple of vendors who we've disclosed vulnerabilities to, because that's what we like to do. And so what you see here is all of the vendors over those years. And Cogent Data Hub, I want to call out as being one of the better SCADA vendors for doing patching. I mean, in fact, one of the first bugs we disclosed to Cogent Data Hub, their CEO actually emailed us and worked with us on the fix, and they fixed it in like 6 days. It was amazing. And they've continued that trend. You know, we've still purchasing bugs in Cogent Data Hub, and they're fixing them relatively fast. But if you look at the big vendors out there, you see, you know, ABB, GE, you know, Indusoft, those over 200 days to release a fix for a zero-day vulnerability that we've purchased that is known. So that's kind of interesting. You know, it averages out around 150 days for bug fixes. A lot of these are going through ICS cert, and so just to kind of call that out. If you look at the SCADA industry and how it compares to other industries, you know, in the highly deployed software, we consider that Microsoft, Apple, Oracle, the big name vendors. They do a decent job. It's about 120 days for them to fix a bug when it's disclosed. And SCADA and security products are kind of battling out for second and third, with SCADA coming in third. And kind of worse of all of them is business software. Things like HP, you know, and other big name businesses like IBM. It takes them a long time to fix vulnerabilities. So, you know, we're almost 200 days for those types of vulnerabilities. So just, you know, as you find bugs and you know, work with ZDI to get them fixed or disclose them directly to the vendor, it does take a significant amount of time, but in certain cases it does take more than just 180 days. So kind of wrap things up, we present at these conferences and provide this level of detail because we want you to go find bugs. We want you to work with the vendors to get them fixed. We want you to work with bug bounty programs like the Zero-Day Initiative to get compensated for your research. And so we are definitely interested in buying vulnerabilities, and that's why we provide this detail. There is ICS, you know, focused malware that is actively exploiting HMI vulnerabilities. These code bases are plagued with vulnerabilities, and you can use those simple techniques to actually find them. It does take a long time for them to fix, but they do end up fixing them. And so we're going to be continuing this research, and we're actually going to be releasing a white paper in a couple months. We're going to release some proof of concepts, and all of our disclosure data is publicly available on our website, zerodayinitiative.com, for you to analyze yourself and draw your own conclusions. Again, we are the Zero-Day Initiative. We buy bugs. If you find 0 days, we are a white hat bug bounty program. We've been doing this for 10 years. We like to watch researchers grow and provide feedback to make sure that they are finding better bugs and getting higher payouts. And so if you are interested, you know, come up and talk to us. We've got basically the whole team here in the front row. And you know, we do a lot of research and look forward to working with you. Thanks for coming and spending the time with us.